Yes. Uh, Good evening, students. I hope everyone is safe and fine and you are doing good. Um, in this session, we plan to take the embedded system laboratory portion. Let me start present my screen. It's a very interesting one. Please take attention. Uh, this is the last session of the today's class. You may little tired. Please bear with us. Sir, is it visible, sir? My slide. Hello, sir.
Visible, Gajendran?
Yes, sir. Yes, sir. Yes. I welcome you all to the Embedded System Lab. Usually, we will take this kind of lab session only in the lab classes. But unfortunately, this time, the same thing, we need to do it in the online mode. Don't worry. We have a wonderful tool to learn this one. It will help you a lot to learn many things. Okay. We are not going to teach much theory here. Only the important points I will tell you. Please make note of it. With the help of that, you can follow the lab very easily. Okay. The very first one is our lab syllabus as usual. You know that the embedded system is the lab embedded theory course. So in lab embedded theory course, the theory portions R is handling, the lab portions we will come to assist the lab. Here, as for our syllabus, we have 12 experiments in our hand. Okay, the first 5 experiments from 1 to 5. Whatever the controller you are studying right now or a processor studying right now, it is an ARM-based controller. With the help of same ARM processor, we can do 5 experiments. Simply go through the experiments. The first one is blinking of LED. The second one is interfacing a switch. Third one, interfacing LCD. Fourth one, 4x4 matrix keyboard. Okay. Then fifth one is the timer operation. Then remaining experiments are we are going to deal with the Arduino. Okay. So what are all the experiments? So since it is a simpler tool to use this exercise, we clubbed a few experiments in a single experiment. Say example, if you see experiment number 6, the first experiment, you need to interface. Wait a minute, let me change the ink color. Yes. First experiment, when you need to interface LED, LCD, relay, and buzzer. Put together, it is experiment number 6. Okay. Then, 7th experiment, we are going to interface a sensor. The first sensor is our temperature sensor. Then, 8th experiment, interfacing of switches and joystick. I hope everyone uses this joystick. Using joystick, you may reach, I think, level 10, level 13, level 14. Like that, you may reach your game. Here, we are going to interface this joystick and we are going to do the experiment. Okay. Then, light sensor. The light sensor, based on the light intensity, the physical parameter of the sensor will get changed. That will give a signal to Arduino, then we can easily process it. Then experiment number 10, IR sensor. So IR sensor, so infrared rays are used as a medium. Using that sensor, you can do wonderful experiments. Okay. Then last 2 experiments, very, very important. These 2 experiments related to serial communication. These things clearly you will study in the theory portion. Don't bother about it. Even though you have a number of serial communication protocols, here we are going to deal with only SPI and I2C. So that thing you can do it with either ARM or Arduino. We will try to finish few experiments. Okay, since we don't have any hardware laboratory to access, we are going to start the experiment from experiment number 6. That means we are going to do the experiment from Arduino. So from this 6th experiment, we are going to do our virtual lab. Okay. I hope this is clear for you. No need to memorize anything. Just take a screenshot of your experiment alone. Okay, that's all. Then, usually, before entering into the lab session, we will show few videos, the real time. See here, we shown an image of real-time vending machine. So there we will show some demonstration how the system works and all. Due to the data consumption, we avoid to telecast the videos. Those videos definitely we will post it in your classroom or in your WhatsApp group. You can watch it. This kind of videos will give you an idea that how you can design any one real-time application. Okay, then sir, is it okay, sir? Shall I continue? Yes. Okay. Students, if you are facing any audio or video issue, please interrupt us. Okay. Thereby, I will stop. Then I will resume back. Okay. Now, it's a very simple block diagram. Please make note of it. In your simplified embedded system architecture, we have seen n number of components. We simplified into little further. Here, only input block, processing unit, and output. Have you come across this kind of block in any one of the laboratory session? Can anyone type it in chat box? Have you did this kind of experiments so far in your laboratory session? One processing unit, one input and output device. Where you did this kind of experiment? Have you did it in a circuits lab or device lab or digital lab or microprocessor lab? Can anyone type it in chat box? Where we did this kind of experiments? Same kind of block already we have used. Can anyone type it in chat box where we have used? Hello? Can anyone respond? Microprocessor lab, very good. See, the same IO board. It's the same IO board. What is the meaning of IO? Input and output. So the input and output, both the blocks, I am going to use only this IO board. This is the common IO board. It has few input and output devices. Can anyone type what are all the input and output devices available in this IO board? You may see in long back. Let me check. How many of them can recollect? First, you tell me few input elements available in this IO board. Can anyone type it in chat box? What are all the input component available in this IO board? Please. Can anyone type it in chat box? Is it the screen is visible? See, please pin my icon, Gajendran P. Then only you can view the lab PPT. What are all the input devices available in this IO board? Yes, very good. See, switches. Where the switches are available? These are all the switches. This is going to act as an input device for my process unit. What are all the outputs available? What are all the output available in this IO board? I have LEDs, buzzer, tricolor LEDs, and relay. These are all output devices. So once I give the signal to the processing unit, in that I have some software component. I have number of lines in it. Once the lines are executed, it will make the output. The output, how I am going to achieve? I am going to use the same IO board with the help of this. Even this LCD is the output device. If you want to display something, you can use this LCD. Okay. Then, what about the processing unit? What is the processing unit you have used in your microprocessor laboratory? Can anyone type it in chat box? What are all the processors you have learned so far? Processor and controller. Can anyone type the variant name alone? That is the model number. If you type, that is enough. What are all the things you have studied so far? Can anyone type it in?
8051, sir.
Yes. Very good. Yes. Wait a minute, sir. Yes, 8051, 8085, 8086. Okay. And what is new here? Here we are going to, wait a minute, let me clear this eraser. Wait a minute. Yes. See, these are all the two controllers we are going to use. Please make note of it. The first one, in ARM, we are going to use the variant name called LPC2148. Please make note of it. The The first one is ARM. This is our development board. This board is available in our lab classes. So if you come, you can see this. Even in some classes, it will show you through the camera. Okay, you can see the development board. This is our LPC2148. In ARM, you have a number of variants. In that, we are going to use LPC2148. Second one, the second microcontroller is your Atmega 328. Please make note of these two numbers alone. Atmega 328. Where it is available? See, this ARM LPC214 is available here. See how tiny it is. If you compare with your 8085, it is very much small in size, isn't it? Yes. Then come back here. Where your Atmega 320 is available? See, this is our Atmega 328. This development board is called as an Arduino Uno. This development board has a separate name that is called Arduino Uno. But the controller name is Atmega 328. Where is the controller available? It is available here. So in today's class, we are going to discuss only this Arduino. In later session, if possible, we will add this ARM also in our lab component. Okay. So far, is it clear for everyone? Shall we move to the next one? Yes. Very good. Now, introduction to the Arduino. Very first one. Only few points in the slide. Whatever the thing you can list it in the red mark. Please make a note of it. The point number one, what is Arduino? Arduino is an 8-bit microcontroller board. Please make note of it. This 8-bit microcontroller board is called as an Arduino. What are all the components available in the board? Point number one, it has onboard power supply. Point number one, it has onboard power supply. Point number two, it has USB port. You may aware of this. In our mobile phone, we are using USB port. Pen drive, it's using the same USB port. So you may aware of this USB port. Then communication with, why we are using the USB port? The purpose of the USB port to communicate with my PC. See, how you did the experiment or how you uploaded your coding into your 8085 or 89S52, you will have some separate loading device. Using the device, you will interface with your laptop or desktop. That is used for communicating between your 89S52 and your PC. Here, in the board itself, you are having this communication feature also inbuilt in the same board. You no need to carry the program loader. Simply in a single board, if you connect it simply to a PC, you can copy the code. Then, what is the other thing? This is the heart of your Arduino board. Arduino board consists of Atmel microcontroller. What is this Atmel? It is the brand name. Atmel is the brand name. They are famous for microcontrollers. They have n number of ICs. If you are interested to learn about the company, go and Google it. Then, what is the another specialty? So first specialty, the board consists of more components. I can control, I can write the program easily by simply connecting my Arduino board with my PC. That is point number one. Then it consists of 8-bit microcontroller. Then onboard power supply. I no need to carry the power supply separately. If I plug it anywhere, I can in the same board I have a power supply option also. So these are all features. Then what is the second one? Can anyone identify? Have you aware of this symbol? Can anyone type it in chat box? What is this symbol called? What is this symbol called? Can anyone type it in chat box? What is this symbol? Can anyone type it in chat box? What is this symbol? Now you can see the full logo. What is the symbol name called? This is the symbol of open source hardware. Which one is the open source hardware? Whatever the board we are going to use is a open source hardware. What it means? Open source hardware means anyone, even you, can get some license, free license from the supplier. They will give you the design also. Then you can fabricate your own Arduino board. Therefore it is named as a open source hardware. ARM is not a open source hardware. That you have some intellectual, ARM industry have some intellectual property. To get the license, you need to pay something that is in dollars. Okay, so it is very huge amount. Individual can't buy the use that particular license. Here Arduino, it is a free license. Therefore it is called as an open source hardware. You can buy the design, you can design your own Arduino board. Then here, what are the points I need to take care? Please make a note the size of the microcontroller. It is 8-bit microcontroller. The whole board put together is called as the Arduino board. Is it only Arduino Uno is available? See in the next slide. There are only few things we have listed here. Beyond this, you have a number of variables in your Arduino boards. Here we have listed 6 variables. One is Arduino Uno, an Arduino Mega, LilyPad, Arduino BT, Arduino Nano, Arduino Mini. Can anyone type it in chat box? What is the difference you are finding in this from the images? What is the difference you are identifying? Can anyone type it in chat box? See, simply you take these 2 units, Arduino Uno and Mega. What are all the changes between these 2 boards? Can anyone type it in chat box? Else you can unmute and answer also. It's very good. Can anyone unmute yourself and answer?
Sir, size gets varied, sir.
What ma?
Size gets varied, sir.
Dimension, very good. Dimension, see the length and width is different. Very good. That's the first point, physical one. Then, as a EC engineer, what else you can view from this? Quick. What else? See, number of pins. Consider here, these are all the pins. Consider here, how many pins are there? See, in your 8085, can you type how many pins available in 8085? How many pin IC it is? Can you type it in chat box? How many pins are available in your 8085 microprocessor or 8051 microcontroller? Can you type it in chat box? Hello? How many pins available? 40, very good. 40 pins. See, if I interface more than 40 IO devices, is it the same IC will support? No. Either I have to procure 2 8085, thereby I can extend the pin number as 40 plus 40, total 80 pins. In that, there are few pins for power and all. You skip those and all. Maximum I can interface 40 devices simply. Okay. If I increase the number of IOs, input output devices, I need to go with the one more IC. That is the one choice. Else, I need to go with the other versions. Here, if you compare with Uno and Mega, the digital input and output pins are enormous in Mega. The name itself, it is clear. So many pins are available. Beyond this, we will interface this many in IO devices in our project. The Mega is too sophisticated. Once you buy, you can't extend your peripheral. This is the system itself enough. But if I am doing any simple automation, as like a automatic hand sanitizer, if I use automatic hand sanitizer, we are going to use only few peripherals. What are the peripherals I want? I need to sense my hand, so I need to use one sensor. Then once I sense the particular one, I need to activate my sanitizer. Thereby, my sanitizer need to deliver the sanitizer available in the particular can. Okay, so there hardly we are going to use only 2 inputs and 2 outputs. Maximum I am telling. In that case, I can come with Arduino Mini, isn't it? So what will happen if I choose the proper hardware unit? I can reduce my component price, so I can compete in the market very easily. So design matrices, the point number 1 is I need to minimize the cost of the product. How I can minimize? First, I need to choose the proper hardware. Then LilyPad, it is a wearable. You can simply wear this one. That means whenever you are doing any defense projects, in army man, in their dress, if you want to stitch something, these controllers, it is not feasible to stitch. This LilyPad, it is a flexible one. You can put it in the any one cloth, you can stitch it, then you can give the power, then simply you can sense it and you can produce the output. Then Arduino BT, here you have inbuilt. Can anyone type it? What is BT? BT means it is a wireless communication. You may aware of this wireless communication. Can anyone type it in? BT can relate with anyone? Anything? Bluetooth, very good. This particular board inbuilt with the Bluetooth communication. So if you buy this one, you no need to buy the additional Bluetooth sensor. Okay. So likewise, you have a n number of variables. Whenever you come time, browse it and choose the appropriate board for your project. But in our lab session, we are going to focus on only Uno. Okay. Then why the Arduino is famous? Why Arduino is famous? So Arduino based sensors, switches, output devices are enormous in market. Simply if you buy and if you interface, you can do wonders with this Arduino. See, this is your Bluetooth device, this is your joystick, accelerometer, DC motor, flow sensor, solenoid, relay, load cell, PIR, ultrasonic. Likewise, you have a n number of sensors and actuators are available, readily available in market. Simply buy and connect it. See, I will challenge you. Within half an hour, you can do one project in your life. Hereafter, once you touch Arduino board, every half an hour you can produce one project. Then count your number of years available in KCE. How many projects you can do. Everything is in your hand. Once you simply go through this laboratory session, and if you learn these things, this input is sufficient to do you the n number of projects in your life. Okay. Then display units and keypad, touch screen. Can anyone type whether the touch screen is an input device or output device? Can anyone type it in chat box? Whether the touch screen is an input device or output device? Why it is both input and output device? Can anyone tell? Why it is both input and output device? In which way?
Yeah, because
Sir, it gives result at the same time, sir.
as well as you can display.
Same time. Okay, then. See, in touchscreen, you have a two component. The one is your touchpad. The second one is the display. Do you have a touchscreen in your hand? Do you have a touchscreen in your hand right now? How many of them carry touchscreen in your hand? Whoever having the mobile phone, having the touchscreen. So 90% of students in this classroom may use the mobile phone as that aiding tool to learn this. Everyone have the touchscreen in your hand. How we can program it? Once you learn these basic things, you can do it by yourself. The 7-segment LED, color 7-segment LED also available in the market. So hereafter, simply you go Google, type something. There you have icon called shopping. I will show you that one. Simply you select shopping, then you come down. There you will find what are all the types available in the particular equipment you can learn. Okay. The very first one, the introduction to Arduino Uno. Hereafter, please take your pen and pencil and notebook. Note only the few things. It is very, very important. The first one, power supply. How to power? See, without energy, even I can't speak. Lunch, I had a wonderful lunch. So due to that energy only, I can speak something. Likewise, any hardware component, simply you say, light area, switch read panna, read panna. We have to give something to work. We have to give some energy. What kind of energy we can give to this Arduino? I can't give rasam more, appalam or something else. I need to give the voltage. Okay, isn't it? If you give snacks, it won't work. So what I need to give? I need to give it. See, very simple. All the microcontrollers are going to operate in direct current. Okay, isn't it? Do you have any doubt with this? Whether I need to give AC supply or DC supply? Can anyone type it in chat box? Whether I need to apply DC supply to the controller or AC supply? Hello, quick. DC, okay, DC, very good. DC supply. Then what is the range? Plus 5 volt. Please make note of this one. Please make note of this one. Plus 5 volt. Point number 1, plus 5 volt. Then where I need to give, see, this is my Arduino Uno board. This is my Arduino Uno board. This is my controller. This is my controller. Okay. To function this controller, I need to give a DC supply plus 5 volt from where I can give. Point number 1. I have 3 different ways to power this one. I have 3 ways to power my Arduino board. What are the 3 ways? Point number 1, USB. Where it is available? See, this is my USB board. See, this is our Arduino. Is it visible to everyone? Is it visible? Is it visible, sir? I think I muted camera. Is it? My camera is not visible right now. Only I made it. Is it visible now? View my camera.
Yes,
Okay, it may be tiny in size. Can you view this one? USB port. Hello?
Yes, sir.
This is our Arduino board. Don't see the slide. See the camera image. This is our Arduino board. This is my USB port. If I connect my USB cable here, simply I can give the power to this. See, if I connect USB cable like this, so is it visible, sir? Yes. Please watch my camera image. See, if I connect the USB cable, I can give 5 volt supply to my Arduino board. Okay, hereafter you watch only my slide. Okay, the first way, wait a minute. Yes, the first way simply through USB cable. What is the voltage I need to give? Plus 5 volt, exactly plus 5 volt. Don't bother about it. The USB protocol, wherever you connect, it will give only exactly 5 volt. I no need to bother about this. Whenever I am using USB cable, free to use it. Okay, it won't give beyond 5 volt. This the protocol, whatever the hardware component inside it, that will take care. Okay, then the next one, power jack. What about the power jack? Where we are using power jack? Can anyone type it in chat box? In mobile phone, we are using power jack. In domestic appliances, where and all we are using? In water doctor, in your where set-top box. If you go and check it, you have a power jack. Using the power jack, if you connect your that male connected to this adapter, it will give the power to my controller. But here, what is the voltage range I can apply it? I can apply, please make note of it. Here I can apply the voltage in the range of 7 to 12 volt. Please make note of it. Please make note of it. 7 to 12 volt. Okay, sir? Then you may get doubt. My controller operating voltage, earlier I told that 5 volt I need to give. Then if I give 7 to 12 volt, what will happen? Whether my IC will withstand or not? Anyone unmute and answer. If I give greater than 5 volt, definitely my IC will get damaged. Then if I give 7 to 12, who will take care? In our electronic devices, we have studied one IC name called 7805. Can anyone recollect this IC? What is the function of this IC? Hello?
Voltage regulator.
Sir, voltage
Very good.
regulator.
Yes, voltage regulator. Same kind of voltage regulator available here. Please take a screenshot. This is your voltage regulator. This guy will take care of the voltage regulation. In general, the voltage regulator have 3 pins. 3 pins. One is the input pin. The last pin is the output pin. The middle pin is the ground. Then what will happen? If I give some extra voltage in these 2 pins, it will regulate and give the supply to my controller. Then why 7 volt? Why not exactly 5 volt? That is your Viva question. Please prepare. Next class I will ask. Why I can't give exactly 5 volt in this power jack pin? The idea and hint, download the 7805 IC and find the minimum voltage what we need to apply to this IC. Next class, anyone remember me? I will ask, then you need to answer. Okay, that is the second way. The range of voltage is 7 to 12 volt. First is USB, the second one is power jack. Third one, what is the third one? We will check. See, let me erase the slide. It looks as V in and ground. 2 pins, potential difference. Voltage means 2 pins. Where are the 2 pins? See, V in and ground. These 2 pins, I given the color coding also. V in means what? Plus 5 volt. Ground means what? 0 volt. So I need to, if I apply 5 volt across the terminal, my IC will work. Yes. Come back quickly. What are the 3 ways? First one is USB. Simply you connect it here. Second one, power jack. You can connect it here. The third one is V in ground. But there is a limitation here. What is the limitation? At a time, please make note of it. At a time, I can give any one mode I need to use. At a time, you can put it as a OR gate, USB, or power jack, or V in ground. We have to give any one way to power by mode. If you connect more than 2 inputs to this board, your board will get damaged. Okay? To avoid that, please make note of this slide. Even though I have 3 options, at a time I need to use only one. Do you have any doubts so far? Can I continue with the next slide? Can I go to the next slide? Yes. Now see, hereafter I'm going to give few pin functions. Take a screenshot, okay? Take a screenshot. The first one, power pins. Make a note of it. Power pin. What are the functions of the power pin? One by one I will tell. See, power pins. These pins are power pins. What is this? Can anyone read this? Can anyone read these labels? Unmute and read. What is the first one? What is first one? Hello, sir. Anyone unmute?
Sir,
What is
reset
first?
3.3 volt,
Reset. 3.3 volt. Then
5 volt,
5 volt. Then
ground,
ground.
ground.
Then ground.
1 V in.
Cherry. Okay. Who is this?
Sairam, sir.
Sairam. Okay. See, can you tell me what is the function of these 2 pins? V in and ground.
Power supply, sir.
Power supply. Very good. To give the power supply to this board. This is one way of powering your Arduino board. How much voltage I can apply, Sairam? Can I give 50 volt in these 2 pins?
No, sir. 5 volt, sir.
Shall I give minus 5 volt, Sairam?
No, sir.
Plus 5 volt. Okay. Next question you should not answer. Okay. Another guy I need. Okay. Okay. You are muted. Now we will see one by one. V in and ground already we have seen. What is reset? See, whenever your mobile phone hangs, the first point, take your mobile phone, bring it to the service person. Is it right? What we will usually do? Laptop. Fortunately, you are doing Java project, I may assume. Okay. Your system gets hanged. What you will do? Take the laptop, go to the Dell shop or Lenovo. What we will do first, can anyone give the troubleshooting tips, how I can bring back my laptop and I continue my work? What we will do? We will reset our hardware unit, isn't it? The same way. If I want to do some, you see, in between program, if my output is not proper means, I can reset it. How I can reset? See, please make note of these are all the female buck strip pins. Okay, these pins correspond to the names they labeled here. You no need to memorize this. If you buy the Arduino board, you can see these names. What is the function of the reset pin? Please, anyone unmute and read this sentence. Can anyone unmute and read? Can anyone unmute and read? This pin will be in pull-up state. Pull-up state can be varied from 1 to 12 volt. What is pull-up and all we will see later. Okay. Whenever I give, see, initially, see the reset pin, initially it will be in logic high. Okay. If I make the pin into 0 for some time, my system will get reset. Reset means it will start run from the known location. Typically, it will start from 0, 0 memory location. Okay. In general, all the microcontrollers, the starting program, they gave given some, says there are some starting address lines also they were given. Power on reset means some line. Watchdog timer reset means some address line. Like that, they given some hardware setup. But simply here we will take the default reset address as a 00. Okay, if it resets, immediately my program will start from the address line of 00. So what is the function of the reset pin? To reset my hardware. That's all. Then what about the remaining pins? What about the remaining pins? Please take the snapshot of this one. See, these pins are 3.3, 5 and ground are output pins. Please make note of it. So far we have discussed only input pin. The reset, VIN in ground. These are all input pins. These are all input pins. Okay. The reset pin also a input pin. Then what about these pins? These pins are output pins. Plus 3.3 volt. First pin. Second one, 5 volt. Please compare here also. Here it is 3.3, this is 5, this is ground. That's all. So the input pin is VIN and ground and reset. Beyond that, I have output. Why I need output pin? Next week I may plan to buy my Arduino board. Then I may buy some sensors. I written some coding. But once I start to execute my output, I need to power my sensor. From where I can power my sensor? Don't go anywhere. Don't search your Amazon or Google. In your Arduino board itself, the additional power supply points are available. Simply take the sensor, connect it here. Whatever the voltage level, check and connect it here. Okay. These output pins to enable your output environment to work. That's all. Do you have any doubts so far? Tell me. Tell me. Shall I continue? Shall I continue?
Sir.
Yes, sir.
Yes, sir. Okay. 135. Okay, very good. Yes. Now you come here. This is your Arduino board. Okay. What are the things we have seen? We will see it here one by one clearly, and some additional points also. Okay. First, the new thing. Please make note of it. Hardware reset pin. See, if you keep your Arduino board in this landscape, the top corner reset button. This is called hardware reset. Hardware reset pin. Manually, you need to press the button to reset. That option also they given. Okay, in the Arduino board, see, this is your reset button. If you press, this is your hardware reset. You can reset. Then next. Please make note of it. USB to serial IC. In this Arduino Uno board, you have two ICs. One is your main microcontroller, your heart of the system. Then the second one is USB to serial IC. At this point of time, please make note of the IC name alone. We will study this one in detail later. Okay. Okay, sir. Yes, USB to serial IC. Then this one, 16 megahertz crystal oscillator. Can anyone type it in chat box? What is the function of crystal oscillator in short? Please, can anyone help me? Can anyone help me? What is the function? Reference clock, isn't it? Reference clock. So this particular crystal oscillator is reference clock for the USB to serial IC. Okay, so this will decide your baud rate of communication. Okay, that and all we will discuss later. This crystal, here you have two ICs and two crystal. The first crystal, what you are seeing here, is used for communication. Okay, then Atmega 328. This is your 8-bit microcontroller. Okay, 8-bit microcontroller. This is one package. Another kind of package we will see in the next slide. Okay, for this controller, microcontroller also, I need to give a reference clock from external. By inbuild from the manufacturer itself, they design one, I think 8 megahertz RC oscillator is inbuilt in this IC. But if you want higher range of clock frequency means you can add the crystal oscillator as given like this. Here the name is little different, ceramic resonator. Please make note of it. Next class I will ask what is ceramic resonator. Anyone need to answer? This is the second question of this today's lab class. Make screenshot, go to Google and browse it. Now you don't go to Google, now listen the class, okay? This is also a crystal oscillator. It has some special function. Please remind me. I will tell you in the next class if you are unable to find. Okay, how many crystal oscillators are available in this Arduino board? Can anyone unmute and answer? How many crystal oscillators are available? Consider this ceramic resonator also a crystal oscillator. How many crystal oscillators are available?
2, sir.
2. Very good. Ceramic resonator
2, sir.
is also a crystal oscillator, but it has some additional function you need to tell next class. Okay. How many IC chips are available? How many IC chips are available? Few more IC chips are available. You leave it that one. Consider this main controller and USB serial communication. These two are important one. Okay. What is take away from this slide? Reset, USB to serial IC, crystal oscillator, main controller, then ceramic resonator. Then if you go and buy the Arduino board, these are all the 2 variables. You have some other boards also available. These are all 2 major things. If you buy, if you will find 2 things here. This is your Atmel 328. But here the package is different. It is quad package. What is the name of the package? Quad package. So this package, this quad package also your LPC, sorry, your Atmel 328. Beyond that, you have one more different also. I will show you here. Come back to the slide now. See, first one, the Atmel 328. Here it is dual in package, DIP. What is DIP? Dual inline package, DIP. Quad package. Quad means 4. All the 4 sides you have a pin, isn't it? This is called quad package. If you comparatively, if you check, the size of the quad package is small, tiny. And one more thing, this IC follows through hole device technology, THT. This IC follows SMD, surface mounting devices. Go and browse these 2 terminologies. What is THT and SMD? Okay. Beyond that, 2 more things. This IC, the USB to serial IC. If you buy this kind of DIP package, here you will have one more same controller here. Same Atmel 328, they will use it for USB to serial communication. But in different kind of boards, they will use another famous serial communication, USB to serial communication IC name called CH340. Please make note of it. This is your driver IC. This IC will take care of serial communication to USB conversion. Whenever you use this kind of Arduino Uno board, you need to use 2 softwares that I will tell you later. Okay. This is regarding the variants available in the market. Okay. Then now I need to make an experiment. For that, I want to know the pin, what are the pins available in my board. I will take hardly 20 minutes. We will finish this one. Please make attention. Okay. Please take the screenshot of this one. Digital pins, digital input and output pins. Please make note of it. Digital and input and output pins. How many pins are available? 0 to 13. The range of pins 0 to 13. Can anyone tell how many pins are available? How many number of digital pins are available? 0 to 13 means how much? 15, correct? 14, very good. Okay, very good. 0 to 13 means 14, very good. 0 to 13. Simply they are labeled with the same thing, 0, 1. Please check the labeling of your digital pins. start from 0 to 13. There are 14 digital pins available. Okay. By default, these particular pins I configure as a input or output. So every pins 0 to 13, I can make it as either input or output. Okay, at a time I can't use the simple individual pin as a both input and output. It is not possible. Okay, you can connect either sensors or you can connect actuators, isn't it? So once you fix the hardware, you are not going to change the configuration of the pin. In few cases only we will do that one. That and all we will see later. At this point of time, these pins can be configured as an input or output. Okay, that is the second point. Third point, pin number 13. Pin number 13 has onboard LED. Please make note of it. Pin number 13 has onboard LED. So there are 14 digital input output pins are available in Arduino Uno. Whatever the thing we are going to discuss hereafter, only you know. Okay, Mega and all, you have a more number of pins. So the first one is digital input and output pins 0 to 13. Okay, 13th pin is also connected to your onboard LED. Can anyone recollect your microprocessor laboratory? The onboard LED connected in which port number? Port pin, can anyone recollect and tell? I forgot it really. You don't tell any pins. Please recollect and tell. Have you found like this any onboard LEDs in your development board in the lab session? Onboard LED? Okay, if you forgot, leave it. We will come to the next point. Next point, please make note of it. Pin number 0 and 1 used for serial communication. Pin number 0 and 1 is used for serial communication. So there are 14 digital input output pins are there. All the pins can be configured as the input or output. Then additional points. Pin number 13 is also connected to the onboard LED. Also pins 0 and 1 used for serial communication. At this point of time, if you are not getting clear concept with this, don't worry about it. Consecutive slides will give you more clarity. Okay. Now, as we discussed in the previous slide, all the pins can be configured as an input or output. By default, these pins are configured as input pins. Please make note of it. These digital pins by default configured as an input pins. So the programmer need not to explicitly declare the pin want to go act as an input like that. They no need to declare. Okay, they can use the pin as the input. Whenever they are using the pin as output, then only they need to configure the pin as the output. Then they need to start use. Okay. Then second point, some of the digital pins are used as PWM. I think you have studied this term called PWM. Can anyone unmute and answer what is the abbreviation for PWM? Sir, konja yaravadu PWM. It is not BWM, it is a PWM. If you learn this, you can buy BWM car. What is the abbreviation of PWM? Can anyone tell? PWM. Exactly, sir. So pulse width modulation means what? I'm not going to ask. Okay, that you go and refer and study. Now see, there are few pins have the special function called a pulse width modulation. See, actually in microcontroller, the advanced microcontroller, each and every pin has more than 2 functions. Okay, in ARM, individual pins have 4 functions. What is the use of it? EC engineer can capable of doing hardware connection. The same person can do C programming. The same person can do Java programming. The same person can do IoT project, isn't it? The person is not going to change, but the person can do the 4 actions. What is the advantage of this one? The company can recruit single person to do the 4 tasks, isn't it? In the same way, in the Arduino board, individual pins have multiple functions. So if you select the mode of operation, you can select these functions. Again, the limitation is the same person can't write the Java program as well as he can't do the IoT project at the same time. So at a time, the pin will do only one function. That mode we need to select. Here, all the digital pins are not capable of handling PWM. Then what are all the pins? Please make note of it. Pin number 3, 5, 6, 9, 10, and 11. Take screenshot. 1 second task. Take screenshot. Pin numbers 3, 5, 6, 9, 10, and 11. So these 6 pins used as a PWM pins. How I can identify, sir? See the tilde symbol. See the tilde symbol is available. If you find the top image, pin number 3, pin number 5, all the pins followed by the tilde symbol. Can view the slide? Is it visible to everyone? How many pins can capable of handling PWM function?
6 pins, sir.
6 pins, very good, that's all. Then, shall I move to the next slide? So far what we have discussed, digital input output pins, pin number from 0 to 13, that's all. Then, analog pins. See actually, in microcontroller project, many of them bought 89S52, isn't it, microcontroller? But whenever you feel to interface some analog sensors, is it possible to interface the analog sensor straight away to your 89S52? Who are all bought ADC in your project? See, if it is 89S52 IC, if I want to interface any analog sensor, analog input, it is not possible straight away to connect it to my microcontroller. What IC you have purchased additionally? What is the name of the IC? ADC. Analog to digital converter. I think 8080, isn't it? 8080 in a number kannadu that you refer. Okay. Here I no need to buy analog to digital converter IC. It's inbuilt 10-bit ADC. Please make note of it. 10-bit ADC. 2 to the power 10, how much? Next class I will ask. Now I don't ask. You make note of the question. 2 to the power 10. Next class you need to answer. Now you come here. How many analog pins are there? How it is labeled? Very simple. A0 to A5. How many analog? Input pin. Please underline the word input pin. Here you don't have analog output pins in this Arduino board. Okay. That means you have an inbuilt ADC, but you don't have inbuilt DAC. DAC you don't have. Digital to analog converter not available. Okay. Therefore, the limitation is these pins I can use it as a only analog input pin. Okay, sir. How many analog inputs are there? Please type it in chat box. Please type it in chat box. How many analog pins are there? Analog input pins. How many analog inputs are there? Okay, 666. Very good. Now, shall I add one more point with this pin? You don't get confused, I think so. What is the function of these pins? It will receive analog input signal. That's all. At this point, you take only this input. Okay. Then, additional point. Please make note of it. These pins can also be used as a digital pins. Beyond this line, I won't explain anything. Please make note of it. I will tell you the reason. Then how we can use it, that and all we will see later. At this point, if I tell, you will get confused. Okay? But you need to make note of this point. These pins can also be used as a digital pins. Okay? That's all. Now, overall recollect. See, what are things you have seen? USB port, power input jack, digital pins, Atmel microcontroller, analog input pins, then power pins, power supply pins, isn't it? These are all the things we have learned in this class. And also hardware button. This hardware push button also you have seen. Okay, with this idea, we will enter into the Arduino coding part. Okay, within 5 minutes we will complete it. Okay, Arduino coding. Arduino coding. C, C++, Java, C, Python, PHP script. See, these are all called programming languages, isn't it? In this Arduino, you know, in microcontroller, what kind of program you have written in the lab? Can anyone unmute and answer? In 18S52, what kind of program you have used? Can anyone unmute yourself and answer? Hello?
C.
Hello?
Embedded.
C
Right.
program, sir.
Embedded C. Have you used embedded C there? Yes, yes. I think in your project you did, isn't it?
Yes, sir.
So I no need to give much introduction about that. Very good. Here also we are going to use same embedded C. In previous batch and all, they learn only assembly code, and so only few students those who did project, they know embedded C. Very good. Here also we are going to use embedded C. This is the comparison. I hope I no need to explain this very much. So C you know very well. Embedded C, see the C is a general purpose program. Embedded C is the it is subset of your conventional C. Okay, how, in which way? C is hardware independent, but embedded C is hardware dependent. In 89S52, you have used some few syntax. The same syntax if you use here, it won't work. Here the hardware changed. Here the hardware, hereafter what we are going to use is the Arduino Uno, isn't it? So based on the Arduino Uno, we need to change the language, isn't it? Then here standard compiler is required. Standard compiler is required. Here cross compiler. That means what? Cross compiler means, see, you did project with your laptop, isn't it? You did project with your laptop. You did project with your laptop, isn't it? But whether you are running the program, whether you are running the program in your laptop or in your additional hardware unit, only during the program we will interface our chip with our PC or laptop. After some time, it will work in a different platform. So cross compiler means if you write a coding in one platform, the same coding will work in the different hardwares. Those compatibility you have it in embedded C, isn't it? If you use the one OS in one system, the same program won't work in the another system. So, okay, so cross compiler means you can use the different hardwares. Your compiler will support the different hardware. Once you dump it, you can start use the different hardware unit. Then compiler generate OS dependable executable file. Here compiler will generate hardware dependent file. Can anyone tell what is the extension of this file? Hardware dependent file? Hexacode, isn't it? Hex file, it will generate and it will dump it into your hardware unit. Okay, that's all. Now, Arduino IDE. How I can use the Arduino IDE? What is the abbreviation for IDE? It is an integrated development environment. IDE. The abbreviation for IDE is integrated development environment. Please make note of this. IDE, integrated development environment. Means what? During development stage, as the embedded system engineer, how they will start do the project means, first they will take some design, they will work out the design, they will simulate it. Once they satisfied with the simulation, then they will start do the prototype. Immediately they won't start do the real project. While doing the prototype, you will come across a number of things. First you will open your software, then you will write some program. Once you write the program, for compile the program, you use in your microcontroller project and all, you may use two different softwares. One is to write the program, and to burn the program, you may use some other tool to upload the program from your laptop to your hardware unit. But in Arduino IDE will support, you can write the program here, then you can compile the program, then you can upload the program into your target hardware is nothing but my Uno board. Okay, so all the things the IDE will take care. In some extent, you can test your program. So using this IDE, I can write the program, then I can compile the program. Okay, I can compile the program, then I can upload the program. So upload has a different name, upload or fuse or burn. These are all the different terminologies used by the embedded engineer. All the three tasks, also the fourth task, what I have told is test. You can test your code in a limited way using this IDE. So all the things are integrated with the one software. Therefore, it is called as an integrated development environment. What about the meaning of these things? You will come to know later in the consecutive slides. If we do, you can learn. So this is the symbol of Arduino IDE. Arduino IDE looks like a inverted 8, and inside you have a plus minus symbol. So this is the logo of Arduino. It is IDE. Again, this IDE is also a open source software. From where I can download, go to Google, type Arduino, then the site will open, then you click download, then you will get a exe file. This particular IDE will support in all the OS, okay, except Android, I think. Android also possible. Even in your mobile phone, you can program your Arduino board. So you have a extended support, Linux, Mac OS, then Windows, in Arduino, all the platform it will work. If you download the software, and you can start do the exercise. Once you download and open your software, this is your main window. This is your main window. It will looks like this. The main window consists of few things. Please make note of it. The first one is the command area. Then this is your text area. Then message area. See, very simple. In C program, what we'll do? Print something. Yes, print something means bottom of the display you will have the print statement. So whatever the command you will type, and if you execute, that will print here. That is the help of this message window. Oh, no, sorry. Here, the purpose of the message window area is different. Sorry. The message window area, it will give the message about your process. Whenever you start do the program, we are doing many things. We will do compile for error checking. While doing the error checking, it will give some error messages in this message window area. By reading the command, you can debug your program. Okay. And also additional information, how many memories used, like that. Some status will display in this window. That is called as message window area. Then text area. Text area is the actual programming window where we are going to type the program. Then the command area is split into three types. One is title bar, menu item, and icon. The title bar consists of name of the project. By default, it will show a sketch. I think this display may not be much clear to you. I will show you in the software later session. Okay. Then minimize icon, maximize and close. Then I have some menu items. As like our MS Office, here also I have some menu bars. See, file, edit, sketch, tool, and help. And I have some shortcut icons. The icons we will discuss later. Okay. Here from this slide, what is the take home point? You can download the software from this website, Arduino, simply Arduino. Type Arduino in the Google, you will get the software link. Click the software link and download the appropriate software. Then menu bar consists of these many menus. So in this we are going to use few menus. Whenever we will use this, that time I will tell you. Okay. At this point of time, please take a screenshot. These are all the few things available here. Whenever we do with the real hardware, at the time we will explain all the things. Okay. That's all about the menu. Then, hello. How many of them present? How many of them present? This is very, very important thing. See, 131 student. Please take a screenshot. Please take the screenshot. Hereafter, only few things I am going to tell you. Very, very important to complete the today's exercise. Okay. The first one. See, Arduino program, the structure of the Arduino program, by default, it is called as a Arduino sketch. So the designer who invented this, they gave the name as Arduino sketch. Sketch means you don't search like a pen. That sketch, color sketch. Okay, this is the structure of the program, the name what they given as a sketch. So the default Arduino sketch consists of two things. One is setup, another one is loop. Okay, there are two functions by default available in the sketch. What are all the function? Point number 1, void setup. Everyone please write void setup, case sensitive, all are small letter, then void gap space you need to give, don't forget this, void space setup, open bracket, close bracket, that's all. Then open braces, close braces. Inside that, whatever the thing we have to write, we will see now. Please make note of this. Initialization or declaration. See, what is your conventional structure of your C program? Can anyone unmute and tell what is the conventional structure of your C program? Can anyone unmute and tell what is the conventional structure of your C program? Header file. Quick. Header file. Hello. Main into main. Then
Open
function declaration.
Function declaration. Then
Function definition, sir.
Function definition. Then. So likewise, your structure will goes, isn't it? Here by default, they given void setup as a one function. What are the things you have to write it here? Be careful. Please make note of it. This function contain a set of instruction for the Arduino to execute once only once. That means, what are all the initialization portion? If you recollect your microcontroller, before start do the project, what you will do, you will declare all the pin numbers. Pin number, this pin number is for LED, this pin number is for buzzer, isn't it? Likewise, you have to declare the function of your pins. So those items you need to start typing this void setup function. Then, even when this particular function will execute, whenever you reset your system or whenever you turn on the system, it will start execute from void setup. How many times it will get execute? Only once. Thereafter, it will go to the next line. Next line, what you have? By default, here you have the function name called void loop. While loop. See, in C program, see, actually embedded C and conventional C, the one major difference is in your conventional C program, you won't encourage infinite loop. If you write while of 1, it is violation of your C program. You should not have the infinite loop in your program, isn't it? If you put like that, your program won't go to the next line. You need to debug, then you need to find where it's stuck up, then you will remove the always true condition, you won't encourage. But see, this void loop is nothing but it is equivalent to while of 1 in your C program. Okay, so it is infinite time this program will execute. What is the sequence? First we will, once you start the program, void setup will get execute. Then it will enter into void loop. It goes to the last line. Then it will come back. Then, whether it goes to void setup again? Hello, sir? Whether it goes to void setup again next time? No. It will again come back to void loop. It will get into this loop infinite time. Okay? Whenever you reset, at the time it will come back here. It will execute once, then it comes to void loop. Okay, that is this. Please make note of this one. Over and over, infinite time. What are the things you need to execute? You need to type it here. See, I am doing the same example. Automatic hand sanitizer. See, if I 9 o'clock we entered our college gate. At the time, if I bring the hand nearby the hand sanitizer, it need to dispatch the hand sanitizer. Then at 4 or 4:30 we will go again. We will have to go to home. At the time, if I show the hand in front of the system, it has to give the sanitizer, isn't it? So 24/7. Whenever you powered it, 24/7 it has to work. So that coding I need to write it in void loop. So void loop is nothing but while of one infinite time this loop will get executed. When my system will come out from this void loop means if I call some other sub function, it will go. Any interrupt program if I write, that time it will go out. Or else whenever I shut down my system or restart my system, whenever I shut down my system or restart the system, at the time it will again go back to void setup, execute once, then it comes here, then infinite time it will start rotate. Okay, what are the two functions available? What is take home here? Void setup, void loop. In void setup, initialization, void loop, main program. Shall we take it like this? Here it is I need to write the main program. Here all the initialize conditions I need to write it. Take a screenshot. Let me move to the second slide. Yes. Now, so what are the things we have studied? Now we need to make it into coding. How I have to make it into coding? See, I am going to teach only three syntax today. Please make note of it. With the help of three syntax, we can finish today's experiment. First one. See, these pins, pin number 0 to 13, pin number 0 to 13, I can use it as either input pin or output pin, isn't it? Here, hello world program. Hello world program means in a C program and all, in double string, you will pass the value as a hello world, it will print. In hardware point of view, hello world means blinking an LED. It is a simple output device, isn't it? That is the task what we are going to do. So please make note of the very first syntax. Please make note of this one, pin mode, this is the syntax, pin mode. Within the argument, I need to pass two values. One is the pin number, the second one is the mode of operation. The mode of operation may be input or output. Please take the example. Here we have given two examples. Here we have given two examples. It is case sensitive. Here M is capital letter, remaining all the letters are small letters. Please make note of it. Here we won't give space between two letters. It will give that is the limitation of your the variable name. You may aware of the programming language. In few languages, you won't introduce the space. So how to differentiate this one? They will introduce the capital letter in between. Thereby, you can read it easily. Okay, or else underscore we will use in some cases. Here they didn't use any special character. Simply the capital letter. Pin mode, pin number. How many pin numbers are available? Pin number, digital pins 0 to 13. So here I can type any pin number from 0 to 13. Output pins what? The particular pin going to act as the output pin. Output means, say example, I can connect a LED. I can connect a LED. Input means what, sir? Input mean what kind of hardware element I can interface? Can anyone unmute and answer? Hello? Can anyone unmute and answer? Input means what kind of hardware setup I can interface? Hello?
Switch.
Very good. Switch. Simple input devices, switch. That's all. Please make note of this syntax. Pin mode, M is capital letter. In the argument, I need to pass two values, pin number and mode of operation. The mode of operation, the output, all letters are capital letters. All letters are capital letters. Take a screenshot. Take a screenshot. Pin mode, that M is capital letter. Output and input both must be capital letter. Okay, that's all. So the point number one, what we have did, now we know how to make the pin as a input or output. Okay, then other functions, how to make the particular pin as a logic high or low. Okay, so digital pin functions, we have few functions, write function, read function. Very first one, what we are going to see is the write function. This is the second syntax. Please make note of it. Digital write, pin number, comma, value. Very simple. Digital pin number, comma, value. Digital means how many states are available? Can anyone unmute and answer? Digital means how many states available?
2 states, sir.
2 states only available, either high or low, 0 or 1, true or false, isn't it? In the same way, see here, digital write pin also, I need to use the digital pin number starts from 0 to 13 only I need to use. So here in our example, they given the 10th pin as high. That means what? In previous slide, I am making, say, example, digital, see, pin mode of pin number 10, comma, output I configure. In the consecutive line, I am going to write digital write of 10, comma, high means what will happen in my hardware. Can anyone tell? Consider this is my Arduino board. This is my pin number 10. What you will receive in this pin? Can anyone tell? High means what logic you will receive? Logic 1 or 0?
1.
Okay, what is the equivalent voltage? What is the equivalent corresponding voltage?
5, sir.
Plus 5 volt. Plus 5 volt. 0 means what, sir? What is the corresponding voltage?
0, sir.
0 volt. That's all. Okay. So digital write of 10, comma, high means in the particular pin, I am going to generate 5 volt. If I make this into low, again it is case sensitive. Please make note of it. All must be in capital letter. Again, write must be, W must be in capital letter. Okay. Okay. That's all. Only 2 syntax we have seen so far. What is the first one? Pin mode 13, comma, or 10, comma. What are the digital pin units? Same pin you can use it. Then input or output. Then how to create the logic. This is write function. Write means what? Arduino going to write something into the external environment. Okay, take it in that way. Okay, yes. Then delay. See, I told we need to blink the LED, isn't it? Blink means what? Blink means what? See, this is blinking. Can anyone see the animation? Can anyone see the animation?
Yes, sir.
Blinking means what is the action really happening over there? Can anyone tell?
On, off.
On, off.
Only on off or on for some time? Off for some time.
On for some time and off for some time.
How I can write the coding? Can anyone help me? How to write the coding? On. Okay, on. What I need to do after some time? I need to pause my controller. You should not do any action for some time. Say example 1 second. After some time second, what I can do? I can turn off the LED. Immediately shall I make the pin to on continuously? I need to realize the off also. I need to introduce the another delay. This is the program structure what you are going to write. On, introduce the delay. Off, introduce the delay. Continuously run the same coding. See, LED blinks continuously, isn't it? So where I need to write the coding, whether I need to write in void setup or void loop. Tell me, sir. Where I need to write this coding, the blinking coding?
Void
Loop. Very good. Very good. So how we can introduce delay? In microcontroller, in 8085 and all, we did number of success. Take 2 registers, initialize the register with some value, then decrement it. Once it comes 0, check the 0 flag, then come to the main program, isn't it? Here, no circus like that. You have a inbuilt functions. You have some inbuilt functions called delay. And within the argument, I need to pass the value. That value will be considered as a millisecond. Okay? Delay followed by, in the argument, I need to pass the value. Okay? There are 2 types of delay functions available. Simple delay. The second one is delay microseconds. Here, The function is very much similar, but here whatever the value you will pass will be considered as a millisecond. Here it will be considered as a microsecond. That's all. Take a screenshot. Take a screenshot. If I pass 1000 in simple delay means it is equal to 1 second. But if I pass same 1000 in delay microsecond means it is equal to 1 millisecond. In other way, here it is 1000 seconds. Here it is, can anyone help me? Here it is 1000 milliseconds. Here it is what? 1000 microseconds. Take a screenshot of the image. Take a screenshot of the image. 1000 milliseconds. That is equal to 1 second. 1000 microsecond equal to 1 millisecond. In this way, you can use it. We are going to use only this delay function for our today's exercise. So this is the task. First exercise, experiment number 6A. So first experiment. So since we skipped the ARM portion and we are going to do only the Arduino portion, the experiment number starts from 6A. Please make note of the today's date, 2/9/2020. Put the date, today's date 2/9/2020, exercise number 6A. Blink an LED connected in pin number 13. The LED should on for 1 second, off for 1 second. This is the problem statement given in your observation material. We will mail the observation material later. If you read the problem statement, you will find the same statement. Okay, how to write the program? If you take your observation material or record material, first we will, as like your microprocessor, we will give some flow chart. Please go through the flow chart first, then you can start write the program. Start the program, configure the pin as a GPIO mode. GPIO mode means what? General purpose input output. Okay, so I need to configure the particular mode as a GPIO mode means, what is the syntax we have studied for this means? GPIO general purpose means, if you configure the particular pin as a output mode means, these two problems will get solved. So see in Arduino, put together we will do the two actions, GPIO mode and output. Both the things using same syntax. Can anyone tell what is the syntax I need to use it for this? GPIO mode and output. What is the syntax I need to use? Pin mode, isn't it? Pin mode. Pin mode, then followed by the pin number and output that you need to write. What is the pin number I need to use? Here they told the blink an LED connected to pin number 13. So this is my output pin. So you can substitute the same pin here. Then, so these things where I need to type, this one, I need to type it in setup loop, void setup loop. I need to type this. Then you come to the loop, make the pin to logic high, introduce delay, then logic low, then delay. Where I need to type this coding? I need to type it in void loop function. That's all. So this is your flow chart. Delay program. So this is the general delay program. Here I am not going to use any kind of this thing. Simply I am going to call the delay function using delay and followed by the value. Okay, here in Arduino, we are not going to use this flow chart. This is inbuilt, it is going to run. This is the conventional delay program. How to write the delay program? To know the concept only, we have displayed over here. In Arduino, simply you write the line delay, that's all. Okay, so this is your program. I will show you the algorithm portion alone. You need to write the program. Please type it in chat box, the equivalent coding. Please type it in chat box. In void setup, what you will type? Anyone type it in chat box? Void setup, what I have to write? Please type it in chat box. Because the same syntax I am going to use it. I am not going to give the coding. Sorry. Void setup. Void setup, what I have to write? Can anyone type it in chat box? என்ன எடுத்திருக்காங்க சார்? Pin mode 13 comma output. Very good. So output must be in capital letter. Very good. Void loop, sir. Void loop. Write 13th pin as logic high. 13th pin as logic high. What I need to write? Quick. Hello? Hello? Digital write 13th pin as high. Very good. Digital write 13 comma high. Delay 1 second. Delay 1 second. Quick. Delay 1 second. Very good. Then digital 13th pin as logic low. 13th pin as logic low. Quick. Very good. Then last, same delay. That's all. This is your program. How simple it is, you see. So now what I'm going to do, we are going to execute the same thing in the hardware portion. Wait a minute. ஹலோ கண்ணா, உங்க கிளாஸ் எத்தனை மணிக்கு முடியுதுடா? ஆக்சுவலா கொஞ்சம் குயிக்கா உள்ளான்னு தான் பார்த்தோம். ஹலோ
சார் 4:30 சார்.
4:30. Okay, I will do one thing. Wait a minute. See, I will give you introduction about the Autodesk software. Wait a minute. I'm audible. Yes, I'm audible. Okay. Kana, within a 5 minutes, let me try to complete. Okay. See, this is Autodesk software. We are going to use it. In the Autodesk, they given one special software called Tinkercad. Make note of this software name. It is a cloud software. You no need to install any software in your PC. Simply you log in. Then their server, they have a software. If you run the program, you can start simulate and you can get the output. And Autodesk have a n number of software with them. The famous software is AutoCAD. You may aware of that. That is the drawing software. In that, they introduced the new software name called Tinkercad. The Tinkercad is famous for 3D design. The mechanical people also using the same software. Using this Tinkercad, you can learn 3D design as well as the circuit design. Okay, I will show you how to log in this software. Go to website, type www.tinkercad.com, then followed by join. Okay, then followed by join. If you click this join icon, here you will have 3 options. In that you need to select students join a class. Please make note of this icon. Students join a class. You need to click this. Once you click, your concerned faculty will give you the class code. Okay, here I have given the example code of ECEB section. ECEB section students, if you take this class code and if you type it here, you can give next icon. You need to click here. You need to type your class code. Then you need to click go to class, go to my class. If you click go to my class, it will ask nickname. The faculty will give you the nickname. The nickname is your same college mail ID. We will give you the nickname once we finished. By default, we plan to give the nickname as your same as your college mail ID. All letters are small letters, not capital letters. So say example 18L210 at kc.ac.in. Likewise, we will give you the nickname. Two things you need to collect it from your concerned faculty. One is your class code. Second one is the nickname. Once you successfully received that, you can click continue, then you go inside, then you will get the dashboard like this. Once you get it in the dashboard, you have a two option, 3D design and circuits. Okay, you need to click the second circuit icon, then go to create new circuit, then you will get the window like this. Okay, now what I am going to do, I am going to enter. See, I will repeat the procedures once again in the next class. Don't bother about it. This is the task what we are going to do. Within a 2 minutes, we will finish the exercise. Okay. See, now just follow me. Whatever thing I am going to do it. Is it visible to everyone? Whether the Google is visible?
Yes, sir.
Visible to everyone? Simply type Tinkercad here. Since I have a login, I can use the login here. What are the procedure you need to do? I will teach you in the next class. Okay. Go to login. I have a login already. Students, for you, we will give you the class login. Okay. In the same login, you can use it. So this is my login page. This is my login page. As I told you already, this is my 3D design. This is my circuits. Okay. Click circuits, then followed by create new circuits. Can you follow me? See, by default, it will show 3D design. In that, we need to select circuits menu, followed by create new circuit. Don't bother about it. Next class, I will explain you in detail. Okay. Simply you go to this page. Here in top, I'm going to change the project name as Hello World or blinking an LED. Whatever the choice you can give. I'm going to keep it as a Hello World. So this is the project title. This is the workspace. Remaining icons one by one I will tell you later. Now, please observe the right-hand side of the software tool. Here find the components list. Simply click this drop-down box. Come to click all. See, by default it will be basic. Now you click all. Then please drag this down arrow gradually. Yes, here you will find the microcontroller. Under the microcontroller, I have Arduino board. See, it is like a simple paint or multi-sim software. You can learn this one. What are the components you need to fetch? Simply click the hardware and drag and drop. That's all. Drag and drop. That's all. So this is the hardware setup I'm going to use. Only onboard LED I'm going to use it. So first I have chosen the hardware setup. Now I need to type my coding. So for coding, go to code menu, click code, then you have a drop down menu, click text. Please take a screenshot of this one. Go to code, blocks and click text. Then click continue. That's all. Somebody written our program already, isn't it? I didn't type anything. By default, my software will have the onboard LED blinking program. Okay. So today I'm not going to type anything. I'm going to use the same code. Okay. Shall we check the coding? Pin mode 13, output. Yes, the first point is clear. Then in void loop, they have written as digital rate of 13, high, delay 1 second, low, delay 1 second. That's all. Now I need to start simulate my coding. What I need to do? See, go to start simulation, click once. That's all. Today's task over. Whether LED is getting blinking, can anyone view this one? Hello, sir. Is it LED blinking?
Yes, sir. Yes, sir.
That's all. That's all. That's all. So likewise, we have do n number of projects. See how much time we took to execute this one, fraction of second, isn't it? The same way we can do it. Sorry. Thank you. Thank you. Take care. Happy learning. Next lab class we will see. Remaining procedure we will post it in the class group. Okay.
Okay, sir. Thank you, sir.
Thanks a lot.